All right. So we are going to do the Unit 6 review. I'm skipping the first 6 problems because they're pretty easy. So we'll start with number 7, where we have to differentiate this expression. So the easiest way, I think, is just to move the 3 down. And we can do this because of the log properties. And then just differentiate this. So the log, all right, log base a of x, the derivative of that is 1 over x ln a. So if we apply this here, the 3 goes to the top, so we get 3 over 3 over x ln 5. So that was a pretty quick one. Now we'll move on to 8, which is 2 to the 5x squared. And again, we're taking the derivative, so we know derivative of a to the x equals ln a times a to the x. So we can just apply that here, ln of a times a to the x, 2 to the 5x squared, and then we have to do the chain rule on this 5x squared, so that's times 10x. And then you can just put that together, and that is the answer. You could, by the whatever, like the power formulas, you could do this and then put the 10 here, just basically moving the x up here. But either way is correct. So yeah, now number 9. Let me copy it down. All right, and we're differentiating. So this one's just a product rule that's kind of annoying to simplify. So derivative of the first term is, I can't even read my writing. Let's see. Oh, wait, no. Okay, we can't use the power rule because the x is in the exponent, so we'll use the formula oh, I wrote it wrong. Whoops. Okay. All right, that makes it a lot easier. So ln 5 times 8x times okay, there we go. Times just this, and then plus just this term times the derivative of this. Is just typical product rule stuff. And then what we can do, we can factor out an 8x from here, and then factor out this whole thing, so we can get 8x 5 like this, and then in parentheses ln 5 times plus 2x squared. So Let me just make sure that's right. All right, going on to number 10. I'm going to scroll. There we go. Number 10, we got logarithmic differentiation, y equals x to the fifth. So it's telling us we need to use logarithmic differentiation. So just take the natural log of both sides. And when we do that here, we can just change it into x to the fifth ln x. Now we just take the derivative of both sides and we get that equals, and then we do a product rule here, plus, it'd be x to the fifth over x, which is just x to the fourth. So that, and then we just take the y and move it over here. And then y equals that. And this goes down here. I don't want to write it, I'm too lazy. But yeah, that is number 10. Now moving on to number 11. Again, I won't scroll. There. Another logarithmic differentiation problem. So we just approach it the same way. For x, and then take the derivative 1 over y. I guess I use the other notation, so x to the fifth, 5x to the fourth, x plus what should be x to the fifth over 4x, and then times, you have to chain rule it, so then you times the 4 here. This cancels. Oops. And then the x turns into x to the fourth, and that cancels out as well. And then you can take this x to the fourth and you can factor it out. So here we're multiplying the y, so this is just y. You can factor it out, so you get plus 4. And then just put everything inside. Oops. Plus, and then 1 because you factored it out. And here's number 11. Now number 12. What is this? Okay, it's just more logarithmic differentiation. Fun. I'm gonna skip the step of writing it out. Just write ln y equals, and when you take the natural log of the right side, we can again use the log properties. So the exponent on the numerator can go down. You get 4 ln 5x plus 1. And then the bottom part, since it's being divided, we can just subtract like this. And it's in parentheses since the whole bottom is being subtracted. And then again, we could bring down the exponent. And then do this, bringing down the exponent again. So this is in log form, and then differentiating it, we get this. This becomes 4 times 5, so 20. All right, here, I'll just show step by step. 4 over 5x plus 1, and then chain rule of this makes this 20 on top, minus x cubed minus 3, and then chain ruling it, you get 3x squared, and then times 5, so 15x squared. And then lastly, we get this on the bottom, and then again chain rule, so we get 6 on top. And we just multiply y times, and then just bring this down. So that is the same pretty much. And I'll skip 13 because it's pretty much the same. So moving on to 14, evaluating indefinite integrals now of the more complex things we've been working on. So first off, these are pretty much just like remembering the formulas. So remembering that the antiderivative of e to the x dx equals e to the x, and then plus c. So we can take out this 5 if that makes it a little bit clearer, and we get that. So very simple there. 15 is a little bit more complicated, but still just using our formulas where the antiderivative of a to the x equals a to the x over ln a plus c. So then we can again take out the constant, -3 times, and then just looking at our formula, this is that. Simple. So 16, again, these first few are just testing our knowledge of the formulas. Antiderivative of 1 over x dx is ln of x plus c. Factor out this 5, we get 5 ln x plus c. Cool. 17. 3 to the x dx is just, what is it? It's this formula again. So just go 3 to the x over ln 3 plus c. Now 18 is just a variation on that, on the, not this one, a variation on 16. So just solve it the same way. We get -3 ln x plus c. And 19 is the same. All right, 19, you guys, I'm sure you can figure it out, so I'll skip this one. That brings us to 20. Okay, now we get a little bit more involved, but still not too bad. 4 sine x over cosine x dx. You could turn this into tangent, but the easiest way, I think, is just u sub for cosine x, which means du over dx will be the negative sine of x. And then, plugging that in. First off, just take out the negative. And then plugging that in is 4 over u times du over, the negative sine of x. And then this cancels out, this cancels out, this cancels out, that cancels out. We're left with 4 over u du, which is pretty simple. Take out the 4, ln of u, which equals cosine of x, plus c. All right, now 21 is negative 1 over sine of x dx, which I don't know if we actually have a, I mean, I'm sure you could solve this, but the easiest way is just to know the formula, which, since 1 over sine of x is cosecant of x dx, and then the formula is just ln cosecant x minus cotangent x, and then bring down the negative and add c. Yeah. Now 22. We're finding the derivative of the inverse function at a. So the, okay, that's not derivative of the inverse, nope, there. So inverse function derivative at a equals 1 over f prime of the inverse of f of x. So for 22, that means f of x equals cube root of x plus 3, and we're solving at a equals 3. So first part, just find what f prime of x is, and f prime of x is just saying, or I guess we're using a. F prime of a is just saying, you could find the inverse function, or you could just say a equals f of x, right? Because the x and the a switch places. This is just saying x equals. So we can just say 3 equals cube root of x plus 3, which means that, so we cube both sides, 27 equals x plus 3, x equals 24. So now we plug that back in here, and we are left with 1 over f prime of 24. F prime of x is 1 over 3. Or here, I'll do, it's a bit easier intuitively. 1 over 3, because we're bringing down this 1/3. 1 over 3, x plus 3, and then we subtract 1. So instead of 1/3, it becomes to the negative 2/3 power. And now we plug in 24 here. So that's 1 over 3. 24 plus 3 is 27 to 2/3 power. And then the cube root of 27 is 3. And then square that, that's 9. So 1 over 3 times 9 is just 1 over 27. But remember that the 1 over 27 is this, only the bottom term. So we have to invert it, and we get 27 as our answer. Cool. And now 23 is same thing, but this time with this, and A is 18. So we'll just say 18 equals 4x squared plus 2. So 16 equals x squared. So x equals, oh wait, x equals 4. And it can't be negative 4 because here we see that x is greater than or equal to 0. Oh wait, that's not right. There we go. So x equals 2, positive 2. And then we're just doing 1 over, which means, remember it's the reciprocal of the f prime, which is just 8x. So 8 times 2 is 1 over 16 is our answer there. Now, if it would scroll, there we go. 24 is, I think we did these in class actually, so I'll just not. 24 and 25 we did in class, so I'll do 26. And 26 is, again, indefinite integrals this time. Oh, this is very this time we're doing the arc trigonometric functions, or the inverse trigonometric functions. So this is very similar to 1 over, right here, antiderivative of 1 over square root of 1 minus x squared equals arc sine of x. So how do we get this, the left part, to match with the right part? Well, the easiest way is just, well, in my opinion, the easiest way, factor out a 25 from the bottom. So we get 1 over square root of 25 parentheses 1 minus x squared over 25. And if you'll notice that 25 is a perfect square. So when we factor it out, we get a perfect square on the bottom, which just makes this easier because we can u sub for u equals x over 5, because x over 5 squared is x squared over 25, and then that correlates with the x squared that we need right here. But it doesn't have to be a perfect square, it just makes it look a bit nicer. If it was a non-perfect square, it would just be like, if it was like 20 instead of 25, it would be x over rad 20. But it still works. In this case, we have nice numbers. So if u is x over 5, du over dx is 1/5. So let's simplify this and put it in terms of u. That means that, oh wait, this is there. 1 over, and then we'll take out the 25 from the radical. So we'll do it like this, 1 minus, and then we insert the u, times 5 du. These cancel out, and we are left with this. Oh, that's not what I meant to do. We're left with this. So we can just apply the formula. We get arc sine of u, and then u is x over 5. So arc sine of x over 5 plus c is our answer. All right, cool. Moving on to, oh, wait, yeah, that was 26. Now 27, we get 1 over 9 plus x squared dx. So this looks a lot like tangent x, or arctangent of x, where we have 1 over 1 plus x squared dx. The antiderivative of that is the arctangent of x. So how do we get this? Well, what I would do is just factor out a 9 from the denominator. And we get 1 over 9, 1 plus x squared over 9 dx. So now we see that we can change this part. I'll try and do this. Ooh, fancy. We change this part into x squared by just u subbing u equals x over 3, which means du over dx equals 1/3. So we can factor out the 1/9, and we can get, plugging in the u as well, we get 1 over 1 plus u squared du, times 3. So then the 3 over the 9 is just 1/3. So this becomes 1/3. 1/3 times arctangent of u. And since u is x over 3, we do this, and that is our answer. There. Cool. And now 28, the penultimate question. Antiderivative of 8x cubed over 9 plus 4x to the 8th. Hold up. 4x to the 8th. Now, the best way, I think, to do it is to use a similar strategy as 27, where we factor out this 9. Because again, this looks a lot like the tangent. There's no square root on the bottom, but we just have this annoying 9 in the bottom. Whoops. So you'll also realize that the square root of this part, I hope this isn't too confusing, but the square root of 4 to the x, or 4x to the 8th is 2x to the 4th. And then when you take the derivative of that, since we have to do du over dx when we substitute, when we u sub, is 8x cubed. And we'll notice that the x cubes, this and this, will cancel out, which means that it will satisfy our tangent formula sort of thing. So first off, let's take out the 9. And now we'll u sub u equals 2x to the 4th over 3, and then du over dx is 8/3 x cubed. So now let's plug that in. 1/9, and then 8x cubed over 1 plus u squared, and then 1 over 8/3 x cubed times du. So this cancels with this. And then this 3 will actually go, not like that. Will actually go here. Since it's 1 over 1 over 3, which is just 3. And that makes 3/9, which becomes 1/3. So 1/3. And then the rest of it is just our tangent formula, our arctangent formula. U equals 2/3 x to the 4th. And then plus c. So that's 28. Yeah, 29 now. The last one. Okay, this one is oh wait, no, this one's not as bad. So it looks pretty similar to the sine, arc sine, I should say. So we just have to get rid of the 4, and we have to get rid of this 3x squared in the top part. And similar to above, we can notice that if we u-subbed to get here, 1 over x squared, or I'll just write this, to get the x squared here, well, x squared is just x cubed, or no, x to the 6th is just, right? So that means if u equals x cubed, we just get x to the 6th equals u squared. So we can substitute u equals x cubed, and we also notice that if u equals x cubed, du over dx equals 3x squared, and this matches this, which means they'll cancel out. So that solves that problem. And then it's just an issue of the 4. So first off, let's do these steps. We can actually, you can do two different substitutions, and you can also do it with just one substitution. So I guess I'll just do it with one substitution. So similar to, what problem is this? Similar to 27. So this problem, remember we factored out the 1/9 or the 9. Here we could factor out the 4. Or no, it's not similar. It's similar to this one, where we factored out the 25 here. So here we can factor out the 4. So I guess 29 combines strategies from 26 and 28. So if we factor out the 4, we get 1 minus x over 4 to the 6th. Oh, this on the bottom. Hold up, let me redo that. We get this. Yeah. Sorry, it's slanted, but I don't know. It's weird to draw on this thing. And then we can do a u sub of u equals x cubed over 2. Then du over dx equals 3/2 x squared, which means we can plug that in and rewrite our equation 3x squared over, we'll take out the 4 again, so we'll do it like this, 1 minus u squared times 2 over 3x squared times du. So this cancels with this. This cancels with this, and we are left with 1 over the square root of 1 minus u squared du, and that equals the arc sine of u, which in this case is this thing. So 1/2, nope, not 1/3, 1/2 x cubed plus c. So that's how you do it with one substitution, where you take out this 4 before u subbing the first time. If you want to do it where you do 2 substitutions, because that's a bit more intuitive, I guess. So 2 subs here. This is how you do it with 2 subs. So we were at, or let's go back to this. Again, we realize that this 3x squared will cancel out with the 3x squared if we use u equals x cubed. So in this, when we have this, instead of taking up the 4 right now, we can just go, okay, u equals x cubed du over dx equals 3x squared. Now we u sub, and we get the original times 1 over 3x squared, I guess times du over 3x squared. These cancel, and we're left with 1 over 4 minus, oh, this should be u squared minus u squared under the radical du. Now, this looks a lot like problem 26, where we have 25 minus x squared. This time we just have 4 minus u squared. So we can employ the same strategy by taking out the 25 here. We were able to u sub in 26. So similarly, by taking out the 4 here, we can get 1 over rad 4, 1 minus u squared over 4 du. And now we'll u sub again, so we'll use v. Yeah, it's kind of confusing here. We'll do it with red. V equals u. V equals u squared over 4, which means dv over du. Nope. Equals, let me see, 1/4, no, 1/2. No, I'm confusing myself. This should be this. What am I saying? Okay, there. V equals u over 2, and then dv over du equals 1/2. So now we just plug this in, and we get 1 over 2, because rad 4 is just 2, 1 minus v, not u, v squared, dv, which we can then just, oh wait, times 2. So this cancels with this. And now we can just rewrite this as, or we could just integrate this. And we get sine, arc sine of v, and v equals u over 2, and u equals, let's see, u equals 3x squared. So we're again left with 3 halves. Wait. U equals x cubed. I looked at the wrong one. We're again left with 1/2 x cubed. or here, I'll just equals u over 2 equals 1/2 x cubed plus c. So yeah, these integrals are pretty tricky. It can be, but you just got to know the techniques. So I guess as a general rule, one thing, if you have 1 over like a radical and then some number a minus some other thing squared, or to any power, I guess, we'll just, like, for example, x to the 4th. Then you can just factor out this a and get 1 over this x to the 4th over a, and then you can just do u equals x squared over rad a in this case. And that's how you would solve something like this. And then the other thing is if you've got 1 over a plus x squared, you just factor out the a again. So 1 over a, that looks like a 9. A. Now it's a d. We'll use alpha. 1 over 1 plus. This doesn't have to be squared. It will say like 8th to the 8th power over alpha. And then in this case, u equals like x to the 4th over rad alpha. And yeah, so this is problem 27 and 28. This is 26 and 29. So yeah, these are good to know. Hopefully that was helpful.